Okay, let's talk about part B. So, we have to write this function here. These are our function inputs. T max is just 3 over f. These inputs come from your fork parameters. In this function, we're going to do all of these calculations. So we've got to calculate our x vector, our t vector, our bk, phi k, ck, omega k, and w. Here's a description of how big these matrices slash vectors should be. Make sure x and t, these are columns. bk is a q by 1, so it has 12 numbers. Phi k is a matrix. ck has 12 numbers, omega k has 12 numbers, and then w is an m by n vector. So first things first, calculate x and m, use your equations. You can also use linspace. Then you're going to calculate all of your z's. Keep in mind, z is a vector with 12 numbers. So when we say zk, that means that z is a vector of 12 numbers, and we are calculating each one individually. Okay, you need to put this in a loop. You do not need to change this line of code at all unless your loop index variable is not k. Okay, so keep that in mind. Then you're going to calculate bk using equation 7b. So just L or zk over L. zk over L. Keep in mind, bk is 12 numbers. It's a q by 1 vector. And then you need to calculate phi. Let's talk about this phi equation for a minute. This phi equation, note this is the entire equation. Phi k, and it's a function of x of m. So we have 12 columns in phi. Each column is a function of x of m. So this is one variable. It's not multiple variables, it's one variable. It has a column corresponding to k and a row corresponding to m, or column corresponding to all the values in x of m. Okay, so keep in mind, when we say bk, we need to grab a number from b, or from beta. And then x of m, this is a vector. You can do this with 2 loops, you can do this with 1 loop. Doesn't matter. Okay, but keep that in mind. For bk, we need to grab each number one at a time, so that when we calculate phi k, we are using bk, so use b1 for this column, use b2 for this column, use b3 for this column, etc. Once you have phi k, then you are going to go ahead and calculate c. So here is your equation to calculate c. This is essentially, think about it as ax equals b, where p is a, c is x, and w is b. So your solution, as you know, is x equals a inverse b, or you can use left divide. Keep in mind, this is p, this is c, and this is w1, where w1 comes from equation 5. Your result is going to be a vector of 12 numbers. Make sure when you do left divide, you're doing it appropriately in the right order. Once you have ck, actually before you get ck, you can calculate wk or omega k. Keep in mind, this is 12 numbers, which means omega k is going to be 12 numbers. It's not an r, that's 12. You have all those pieces. Now comes the hard part. The hard part is calculating w. So W is a matrix. W is a matrix of 201 rows, 501 columns. For each number in here, we need to do the summation. So for each number, we need to do the summation. Remember, this is a summation. When you are summing numbers with a loop, you need to initialize your sum to 0 before your loop. And then inside your loop, you need to say s equals s plus your new term. Okay, so you need both of those pieces in order to calculate w because you're doing a summation. Note the summation is over all of your k values. So that means you're grabbing this one at a time. So grab one number from ck. Grab one number or one column from phi k. ck is a vector, you need one number. Phi k is a matrix. So you need a row and column indicator. What row and what column are you grabbing from phi k? Oops, sorry. And then omega k, grab each number, and then Tn, grab each number as well. So you can do this in 3 loops, 4 loops, or two loops or 3 loops, it doesn't matter. But note we've got lots of different variables at play. We have m, we have n, and we have q. Okay, so we need to account for all 3 of those pieces when we are calculating w. Once you have w, then you're done with your function, and you can celebrate, you can do all your comments, and move on to part C.